everybody, in this video I'm going to be taking a look at a couple of very quick questions from section 7.1 in the honors analysis assignment. Specifically, I'm going to be looking at number 27, number 30, 31, and 33, all of which are relatively quick, okay? First of all, I'm going to be looking at number 27, okay? Number 27 is asking me to convert 9 radians to degrees, okay? And it's not saying 9 pi radians, okay? We know that pi radians is 180 degrees, and if that was the case, you just multiply 9 by 180. Because you don't have that 180 here, this is a little bit more complicated, okay? So I kind of just took you all through kind of a common sense. I want you to be able to look at radian and degree measures and go back and forth. You know, I want you to be able to see pi over 2 and say, oh, that's 180 degrees divided by 2, that's 90 degrees, okay? I want you to be able to look at 2 pi over 3 and say, oh, I'm taking 2/3 of 180, okay? 1/3 of 180 is 60, 2 60s is 120 degrees, okay? I want you to be able to look at 5 pi over 4 radians and say, okay, pi radians is 180 degrees, 1/4 of pi radians is 45 degrees, okay? If I take 5 45s, that's going to be 225 degrees. I want you to be able to do most of those kinds of things in your head, or at least really quickly on paper with a calculator, okay? Now, this one's a little bit different because it's 9, okay, not 9 pi, all right? There is no requirement that radians have to be written in terms of pi. Because they tie to parts of a circle, it's more common to do it that way, but it doesn't occur that way every single time, okay? Now, let me show you a couple of approaches here, and you don't have to use any one of these, but different things that can work, okay? Let's go to something simple first, okay? Let's say that I wanted to turn, let's do pi over 3 radians to degrees, okay? This can't be done with ratios, okay? Other than maybe solving equations, maybe graphing straight lines, you can make a pretty strong argument that the single most important thing you learned in middle school was proportions, okay? Because quite honestly, most of the math that you're gonna use, if you're not in a STEM math field, maybe that's not you, maybe that's your friends, but most of the math you're gonna use in the future, short of like measuring and that sort of thing, is probably gonna be proportional reasoning. Okay, so you know, keep in mind there's a ratio between radians and degrees. Okay, and it doesn't matter which way you compare that ratio, but that ratio always has to be the same. So for every pi radians, it's going to be equal to 180 degrees, or if you want to say every 2 pi radians is equal to 360 degrees, whatever you want to use, you want that straight conversion. Okay, so the ratio of radians over degrees will always be the same. So if you have pi over 3 radians, you can fill that in the top of the fraction, and you can put an x in here. That's the number of degrees, okay? Radians over degrees always has to work out to be that same ratio, okay? And you can cross multiply here. If you cross multiply here, you're going to get, let's see, that's going to be 60 pi is equal to x times pi. And you can see that in this case, x would be equal to 60 degrees, okay? Is that a faster way than just saying 180 divided by 3 is 60? Heck no, okay? I wouldn't do it that way for most of these. However, proportions can be really helpful if maybe you're psyching yourself out, or you know, something just hits you wrong, or they give you something weird that's in a form that you're not used to, okay? So, same kind of thing. We know that pi radians is always 180 degrees, okay? That ratio always holds, okay? So I was given a number of radians. I know it looks weird to put it here when there's no pi, but that's the radians part of the ratio, okay? And we want to figure out the number of degrees, okay? This ratio has to be the same as that ratio. That always holds, okay? So you cross multiply here. I have no idea what 9 times 180 is. All right, 1620. And that's equal to pi times x, okay? I'm going to divide 1620 by pi. And by the way, you could leave this as 1620 over pi. That's fine. I'm guessing most of you would kind of like to know like 9 radians, you know, a decimal equivalent. So certainly we can divide that out, and we can get a decimal equivalent just to give you something to think about. It turns out 9 radians is about 515.66 degrees. Okay, again, if you want to leave it as 1620 over pi, that is totally accurate, that's correct. A rounded answer would be about 515.66, okay? That's probably the way that most textbooks would tell you, or if a textbook gives you a formula, the formula is probably going to come back to something having to do with that proportion, okay? Now, that being said, are there other ways to do this? Sure, there are other ways to do this, just kind of common sense. I think in general, you should know about how many degrees there are in 1 radian, okay? So if pi radians is equal to 180 degrees, that's about 3.14 radians, okay? So if I wanted 1 radian, if 3.14 radians is 180 degrees, you can divide by 3.14, or specifically divide by pi, and you'll get the measure of 1 radian. So 180 divided by pi is about 57.296 degrees. Okay, 1 radian is just a little bit less than 60 degrees. Okay, remember, only 3 of them. Pi units is 3.14, so it takes about 3 radians to go all the way around a circle. So again, that would make sense that each radian is about 60 degrees. Okay, and so then if you wanted 9 radians, you could take that and you could multiply by 9, and of course you're going to get that same 515.662. Okay, so lots of different ways you can do that. All right, now on to the other questions, which are much faster. Question number 30, they ask you for coterminal angles to pi over 4. Pi over 4, by the way, is about 45 degrees, exactly 45 degrees actually. Remember, coterminal angles are just angles that have a terminal side in the same position, okay? So this angle would start out here along 0 degrees. You would rotate 45 degrees, that angle would look like this. A coterminal angle would be an angle that ends in the same place. This is called the initial side of the angle, this is called the terminal side. So a coterminal angle would be an angle where you continue all the way back around and your angle ends right here. So you can just add 360 degrees to this, or in this case, since this was done in radians and not in degrees, remember 2 pi radians is 1 complete circle. So you can add 2 pi to that, okay? So this is 1/4 pi plus 2 pi. That would be 2 1/4 pi. Honestly, we don't usually write it as 2 1/4 pi. We usually leave it in improper fraction form. So you could write this, for example, as 8/4 pi. And that would leave you with 9/4 pi, or 9 pi over 4 is probably how we would write that, okay? Now, the other way you can do this, you could rotate backwards. Remember, if you go clockwise, it's a negative angle measure. You could go backwards 2 pi radians, or backwards 360 degrees, and you'll have another angle that ends at the same place, okay? So for every 2 pi you add, or every 2 pi you subtract, you're going to get another angle that would look the same if you graph it. It's going to end in the same place. So that would be pi over 4 minus 2 pi, okay? 2 pi again is 8 pi over 4 if you want to write it as fourths. And 1 minus 8 is -7 pi over 4 is how you end up writing it, okay? So those would all be coterminal. And again, if you want to do this in degrees, and you want to do 45 degrees, and you wanted to add 360, and then you wanted to convert that back to radians, that's fine. If you wanted to do 45 degrees and subtract 360 degrees, and then convert it back to radians, that's also fine, okay? Same kind of thing with number 31. At this point, this should be the same thing. They give you 11 pi over 6. Okay, so again, if you want to convert that into degrees, 180 divided by 6 is 30. 30 times 11 is 30 times 11 is 330. And you could do it as that. But again, I would just do it straight with radians, okay? So 2 pi radians, you could be added to that, or 2 pi radians could be subtracted from that. Again, you probably want to turn this into sixths. 2 is the same thing as 12 sixths. So you have 11 plus 12, that's 23 sixths pi, or usually you write that as 23 pi over 6, okay? And if we subtract 2 pi would be the same thing as 12 pi over 6 if we were writing it as 6, and that's going to give you -1/6 pi, or -pi over 6. So all 3 of those angle measures would graph in exactly the same position, okay? If you start out with your 0 degree along the x-axis. All right? Okay, last question here, 33. It's the last of this set of questions. Okay, so number 33 gives you a circle with a radius of 8, all right? And they give you an angle measure that's 7 pi over 4 radians, okay? You might, just to visualize what's going on here, you might want to convert this into degrees. Remember that pi is 180 degrees, so you're taking 7/4 of 180, okay? 1/4 of 180 is 45, so you're taking 7 times 45. 7 times 45 is equal to 315 degrees, okay? So this would be all the way around like this. It would be a 315 degree angle, okay? That's what we're looking at here. And they're asking you for the arc measure. I think that means they want the length of that arc. I would have to go back and look at the original question. But anyway, what we're basically looking at here is a part of a circumference, okay, a fractional part of a circumference, okay? Well, remember that the circumference of a circle is 2 pi r, okay? So in terms of pi, the circumference of this circle is going to be 16 pi, okay? And we're taking that fractional part of 16 pi. Okay, so if you want to do this in degrees, because that's your kind of natural instinct, remember this is really just a proportion. We're just taking a fractional part of the entire circle. Okay, we want to know what fractional part. So we're taking a part that is 315 degrees out of a whole of 360. And if you simplify that fraction, 315 divided by 360 is going to simplify down to, it's actually 7/8. Okay. Is that overall fraction. So I'm really taking 7/8 of 16 pi, and you guys probably know from middle school math, most of the time when you use the word of, it suggests that you're going to be multiplying. 7/8 of 16 pi, 1/8 of 16 pi would be 2 pi, and then 7 of those would give us 14 pi, and that would be the part of the circumference that we're looking at. Okay, now you could also do this with radians. Radians would work great here. It's still just a part to whole comparison. Your part of the circle is 7 pi over 4 radians. Your whole circle, remember, is 2 pi radians. That's the same thing as 360 degrees. And you can just simplify that fraction, okay? So if I had 7 pi over 4 compared to 2 pi, I do a couple things. First of all, I multiply the top and the bottom by 4 to get that fraction out of the numerator of the fraction, okay? And that would give you 7 pi on top, and that would give you 8 pi on the bottom. And then you can divide pi out of the top and the bottom, and you can see that this is really 7/8, okay? So again, just like with degrees, we wanted 7/8 of the circle, okay? 7/8 of a circumference of 16 pi would just end up equaling 14 pi. And I didn't see there if there were units, so you can add those. But that's the basic idea. So lots of proportional reasoning, lots of fractional reasoning, you know, good connections back to middle school reasoning, combined with some more sophisticated things like working with radians.